Good morning students. This is Kiran Kumar, Assistant Professor from EC Department, Institute of Aeronautical Engineering, Hyderabad. Today we are going to discussing about the Digital Communication Laboratory. So in that we have delta modulation and demodulation. So what is the difference between delta modulation and previous pulse code modulation? Basically in pulse code modulation, number of bits per sample is more than 1. So due to that, we have a redundancy problem in PCM. So to overcome that problem, we will go for the delta modulation. So in this case, we have to transmit only 1 bit per sample. So the transmission rate is increased and bits per samples also can be reduced. So due to that reason, the bandwidth also can be reduced in delta modulation. So now let us see how to connect delta modulation modulator circuit and demodulator circuit by using the trainer kit. This is the delta modulation and demodulation trainer kit. So in this we have a modulating signal generator, which is basically a audio frequency signal, which means a low frequency signal. So by using this modulating signal generator, we have to generate a continuous time signal, which is a sinusoidal signal, that is the input signal. Now let us see the second one, that is the bit clock generator. So by using the clock generator, we can perform or we can generate the clock signal. So after generating clock signal and modulating signal, we have to give these two signals to the modulator. This is the modulator part of the delta modulation. For this delta modulator, we have to give two different connections. The first one is the modulating signal that is taken from the modulating signal output. So after giving this connection from modulating signal output to the modulating signal input to the delta modulator, and now coming to the second connection, that is the bit clock input. So the bit clock input is given from the clock generator. So from clock generator to bit clock and from modulating signal to modulating signal, we will get the delta modulation output. So delta modulation output. So internally, what will happen in this case? Basically, by observing the delta modulation circuit, the approximation study can be done by the delta modulator. So it can identify the previous data with the present sample value, that is past sample and present sample can be compared by using this comparator after giving these two inputs, that is clock and modulating signal to the delta modulator. So it performs a staircase signal from this pin. So the staircase signal can be performed in terms of comparisons of the frequencies. That is, the previous sample and present sample can be compared. If the previous sample is less than the present sample, the delta, which means the staircase signal, is increased by 1. If the previous sample is less than the present sample, the delta from here, that is the staircase signal from the delta modulator, is decreased by 1, which means previous sample and present samples both can give the ones and zeros. If the sample is increased, which means if the staircase signal, which means if the step is increased by 1, which means the data 1 is transmitted. If the step is decreased by 1, the data 0 is transmitted. Now let us see step-by-step connection of the delta modulation. First of all, I am going to verify the input signals, that is modulating signal. So this is the variable modulated knob. So by changing this knob, we can observe the variations in the amplitude levels. So see here, this is the output waveform of the modulator. So from this modulating signal generator, this is the modulating signal generator. By using this circuit, we will generate the modulating signal. This is the input signal. So after generating this, we have to calculate the values by using measure option. So you have to note down the input signal values, amplitude and frequency. And next we are going to go for the calculation of tag signal. See here. So this is the clock generator. So I am applying the clock generator. See here, this is the clock generator output knob. So from this clock generator output knob, I am connecting channel 1 to the DSO. Now let us see, this is the clock signal. This is the clock signal. In terms of clock means carrier signal. So by applying these two to the delta modulator, we will get the delta modulated output with respect to step signal from this point. Now let us see the connections in between modulating signal generator to the delta modulator. The first connection from the modulating signal generator, from here I am going to connect the delta modulator signal input. So modulating signal output to the modulating signal input, and the second connection is clock generator. So from the clock generator to the clock input. Here we have bit clock input and clock output. So after connecting these two, I am going to verify the staircase signal. So I am not going to verify the delta modulated signal. So before going to identify the delta modulated signal, so I am going to verify the step signal, that is the staircase signal. Here you can observe the staircases of the delta modulated output. See, this is can be happen due to the comparator of the delta modulator. So the comparator compares the previous samples. These are all the sample values. Each and every step indicates one sample. Each and every step indicates one sample. Here you can observe this. These are all the step signals. So by comparing the steps, see here one example. Here I am going to give one example. Or suppose this is the present sample. Just consider this is the present sample and this is the previous sample. Okay, present sample and previous sample can be compared together. If the present sample is less than the previous sample, the step size can be increased by 1, which means if the delta, that is step size increased by 1, the corresponding sample transmits 1. Okay, now let us see the second case. If suppose if the present sample is this one and the previous sample is this one. Okay, the present sample is less than the previous sample, the step size is decreased by 1, which means at this particular case the 0 is transmitted. So by using this comparator, the comparison can be done like this. Okay, based upon the comparison of the present and previous samples, we will get the step signal as like this. Now let us see the output waveform of the delta modulation. Here I am verifying the staircase signal. Now coming to here, delta modulation output. Before going to identifying the modulated output, I am just giving one clarification regarding to the comparison of the input signal, that is comparison of the modulating signal, how the steps can be converted in terms of staircase signals. Okay, so I am going to give comparison. See here. See, after comparing the input signal and output signals, input signal and output signal, we will get the see here, see on the screen, we will get two different values. Now let us see here. See here. So this is the input signal, and by using this input signal, we will get the staircase signal. Here you have to note down or you have to calculate the error of the delta modulation. Okay. So this is actually what we call this error means this is the slope overload distortion. Slope overload distortion. And second category is the granular noise. Granular noise. Here the step size is very less than when compared to the input signal. When compared to the input signal, step size is very less. In that case, we have to note down the error, that is staircase error. Sorry, that is slope overload error. And second one is the granular noise. In this case, the step signal is very high when compared to input signal. So to reduce these two errors, that is slope overload and granular noises, we have to choose the adaptive delta modulator. In that case, the step signal can be increased up to the level of the input signal. Okay, so that's why after performing the delta modulation, you have to reduce these two errors. We will go for the adaptive delta modulation. Okay, now let us see the delta modulation output. Basically, what is the output of the delta modulation means? We have already discussed the output of the delta modulator means the transmission of ones and zeros, which means the transmission of 1 bit per sample. See here, after comparing these two, the input signal is continuous signal, that is indicated with blue color. This is the input signal. That entire data, we have only one sample, that is 1. That is 1. And one more thing, see here. So from here to here, the signal is increased. The signal is increased. I already told you in terms of staircase signal. So if the step is increased, the one is transmitted. Up to now, here, that is steps is increased. From here to here, the signal is decreased, which means the step signal is less than the previous value. So that's, in that case, we can transmit only 0 values. That's why ones and zeros combination of the delta modulation can be performed. Okay, so this is about the delta modulated output. Now let us see the delta modulation demodulation. Delta modulation demodulation. See here, this is the delta modulated kit. So in this delta modulated kit, we have to give delta modulation input and clock input. So same clock can be given from here, and the modulated output, that is the DM output. So same DM outputs, from DM output to delta modulation demodulator input, one connection, and second one is the same clock bit input is there. So same clock can be given here. Same clock is given here. And let us see, here we have the output, that is demodulation output. So this is the low pass filter. Before giving to the low pass filter, you will get the output is like this, like a ramp signal. So if you can give the low pass filter connection for smoothing our filter, I am going to change the connection. So from output to low pass filter, one connection is made from output to low pass filter, and the output is taken from this pin. Now let us see the output from the filter circuit. So after connecting the filter, we will get the output is like this. So this is the exactly what we transmitted from the input side. So this is the demodulation of the delta modulation. Okay. This is the delta modulation and the demodulation process. In terms of ones and zeros, we have to transmit the number of samples per number of bits. Okay, we can reduce the number of samples by using delta modulation. For each and every sample, we can transmit only 1 bit. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.